So what we're here for tonight, we're basically going to talk about introduction to programming, but mainly introduction to web development. So we'll talk about the difference. There is a pretty significant difference, but we're going to cover both of those topics in a relative level of depth, but more of an overview. So these are big topics. This is what we cover in 6 months. Even in those 6 months, that does not cover anywhere near the complete version of web development. But along with that is the fact that nobody has the complete knowledge of web development at all. There's not one person who is a master of it. It is a huge, huge discipline. It's like saying one person who knows everything about music, I was going to say. But then again, I do know some really annoying college friends who claim to know everything about music out there. But it's more like, I'm trying to think of a good example. You know a small section of it. And that's really what matters. You know 1 or 2 languages. You know 1 or 2 frameworks. And then from there, you can learn everything else that you need to learn. So it's really different in from a lot of disciplines that you may be familiar with. It's certainly different than the stuff that I studied growing up. The way, the approaches to learning, like math or biology, for instance. Bio is a really big example, actually, because I've noticed that almost all the bio majors that I've worked with or that I end up teaching have a certain set of habits that they've kind of been groomed to have based off of their experience learning bio in college or in high school, where it's just a lot of memorization. Like when I took bio classes in college, it was reading a textbook. I made this huge study guide, tried to memorize it all, and then I showed up for a test and spit it all out and then forgot it just a few weeks later, if not a few hours later. Web development is completely different than that, where there is no emphasis on there is definitely an emphasis on web development. There's no emphasis on memorization. Okay. So memorization is something that is a really hard skill to break. So what I want to make clear, though, we're going to show a lot of stuff tonight. Do not focus on knowing it all. Don't feel like, holy crap, I don't actually remember half of what they said. That's kind of the point. This is going to be a little bit of a blitz. We're going to cover a lot of different things. Some of them are going to make a lot of sense. Some of them might be a little confusing, especially if you've never seen them before. But don't have that temptation feel free to write down notes, take anything that you want, but don't feel like you need to just copy every word down that we said. It's really about knowing how to find information. This is something my students hear all the time. It's about knowing how to find something out rather than remembering it. So you don't need to know the syntax for how to write 200 lines of JavaScript. You need to know how do you find out online how to do that, or how do you look it up? How do you read someone else's code that does it? So anyways, that's a long preface to this whole thing, which is we're going to show you a lot. It's going to be all over the place. It's all related to web development, but that's a huge, huge topic. So we're going to cover everything from, and I have a slide on it actually, just here. Everything from introduction to programming languages, what is programming, talk about web development, how it's different than programming, talking about more specifically back-end and front-end development, client-side and server-side, what's the difference, static versus dynamic pages. We'll talk about how the internet works, pretty important topic to understand how to make websites. And then we're going to go into some more of the details around specific frameworks, libraries, APIs, modules that are out there, databases, also very important. And then we'll write a little bit of HTML and CSS, and we'll show you some JavaScript as well. You're not going to leave here, an expert in any of those topics at all, but you'll leave here at least being familiar with some of them. And so next time you see them, hopefully, you have something to grab onto. You have a little spot in your mind to put some more knowledge into. So that's really the goal here, is just to expose you to a lot of things. And so all of this, just coming back to our shameless plug for our class that we have going downstairs, the web development 6-month program. All of this is taught in the class probably in the first day or so. And from there on out, we cover all these concepts all the time, but they're the foundation of the class. So it's not like you learn this once and then you're done. This is something that we cover every single day. All of these topics, this week alone, we're in week 8, and we've covered pretty much every single thing on here. And we hit them every week. And we just start doing more interesting things, more advanced things. But they're all built, every project we do, every lecture is built on these fundamental concepts. So really important stuff, and really exciting things as well. And then the last thing we'll discuss is where do you go from here? Whether it's taking a class, a part-time class, a workshop, buying a book, YouTube videos. There's all sorts of different ways to learn this. And I don't want to make it seem like the only way to learn it is coming here to a similar program to take a 6-month class. It's definitely, in my opinion, the best way to learn it, but a lot of us here, I mean, both of us had different experiences. So it's definitely, I don't want to make this seem like you have to, go to a class to learn this. It's just a really good way to do it. But we'll talk about just some other steps and other opportunities for people who can't spend 6 months of their life or 3 months of their life. So definitely want to make that clear. So let's start. Go ahead, Ellie.
Oh, what is programming? Also, another thing, let's keep this casual. So any questions you have, please feel free, yell at us. It's absolutely fair game. This is really a time for you guys to learn as well. So let's all do that together.
And we totally missed this. Molly introduced us before.
That's
the
right.
pizza,
Yeah, we should tell them who we are.
But I think pizza distracted everybody. We had a few new people come in. So I'm Colt. This is Ellie. We're both instructors here at Galvanize in the class that we have going on right now. 6-month full stack immersive. Molly talked a lot about it. We'll talk a little bit at the end about it. But we both teach here full time. We do this kind of stuff all day. Yeah, that's pretty much it. Ellie and Colt.
Cool.
All right.
So I think this is great. It's a great question to ask you guys because we're going to be talking a lot and definitely want to get you guys more involved with this. If I was a 6-year-old and I asked you, I'm not a 6-year-old, thankfully. If I was a 6-year-old, what is programming? Give it a shot.
Writing language to make things work.
Okay, so writing languages to make things work. All right, I like that. So we're writing something to make something work. Nice. So we're trying to solve something. Any other thoughts? That's a really good one. Don't all speak at once.
And it doesn't necessarily have to be related to writing code specifically or computers.
Yeah.
Instructions.
Ooh,
Okay. That's
there
a
we
good
go.
one.
Go students. Yes. Yeah. Okay, so instructions are a set of instructions to perform some kind of task.
So what's a type of, if we're saying that programming is a set of instructions, what is a set of instructions or a type of program that we might use all the time?
Recipe.
Exactly. That was the one I was looking for, but there's plenty of other ones out there. So something like a recipe, you could consider a program. So it doesn't necessarily have to mean sitting at your computer and writing code all day. I mean, that's generally what programming refers to now. But any set of instructions, any step-by-step process, that is what programming is at its core. When you sit at a computer and you write 1,000 lines of Ruby code or Express code, that is just a set of instructions to the computer. And that's all it is. Your computer goes line by line and reads it and does something based off of what you tell it to do. Just like when you're reading a recipe, hopefully you're going line by line and you're doing what the recipe tells you to do. You're getting the right ingredients, you're mixing them, you're turning the oven on, whatever it is, it's a set of instructions that we can read. So what we're going to focus on is creating sets of instructions that computers can read, and there are very specific rules, very specific language that we have to live within. Sort of like with recipes, there's like this common language that emerges. So in recipes, you might often see things like preheat oven to 450. That doesn't have to be explained to you what that actually means. But there's a lot of information encoded there. Anything from like get up, own an oven first, open the oven up, make sure there's nothing in there. Some of you may not do that. But close the oven, find the button display, turn it on, type in 450 or turn a dial, and wait until it beeps or whatever, however it notifies you. There's a lot of stuff there, but you can just say preheat your oven, or you can say mix thoroughly, or recipes can give you this set of language that kind of compiles into these more lower level things that you just know about. So you know what it means to whisk something or and some of the more complicated things, like trying to think, I'm no chef, but like sous vide or to do some, creating like meringues or something, or taking
French random word will work.
So there's a lot of these words that are much more complicated, and they're like these higher level terms, and that's just like what programming languages are. So instead of saying something like beat egg whites into I don't know, I'm totally at a loss for cooking stuff. How about we go back to preheating the oven or something? Yes, stiff peaks. Let's do that.
Just come
create.
on. Come on.
I was doing some candy cooking the other day, and you have to get the sugar to a very specific texture. I think it was called softball. And so if you know what that is, that's a lot of work that you don't have to follow instructions for. That's probably like 50 lines of code that you don't have to know about. So programming is just like that. We can say something like, make this page have a spinning image with a dancing border around it that changes from purple to pink. And you might write that in 5 lines. But behind the scenes, that turns into thousands and thousands of lines. Eventually, that's going to turn into ones and zeros way, way down the line. And so the point here is that there's all these levels of abstraction, just like there are with whatever you're good at. Everybody here has something that you're good at, whatever it's your job, your hobby, your passion. You know how things work, and you don't have to start at the basics every single time you do something, whether it's cooking, even getting dressed in the morning, making a sandwich. To open up, so there's a classic programming example, first day of computer science class, which some of you may be familiar with, which is my professor would show up with peanut butter, a jar of jelly, a knife, and a loaf of bread. And he tells you, or she tells you, I am a computer, I'm a robot, I'm going to make you a sandwich, that's what I'm good at, tell me how to make a sandwich. And so I remember this very clearly. The first thing that we all shouted out to the instructor was pick up the peanut butter, or actually no, it was open the peanut butter. And that's not a very specific direction, open the peanut butter. So what he did was he picked it up and he just started slamming it on the table over and over and over. And they said, no, unscrew it. So he unscrewed it, and then we said, put it down. And so he just threw it down on the ground. And peanut butter literally went all over the place. It was the messiest day in that classroom. But more importantly, it really illustrates an important point, which is when you're programming, you have to assume that your computer is sort of an idiot. But along with that, you can also say things, and the whole point of programming is that we don't have to write these ones and zeros, we don't have to write these super low-level instructions. I can say something like, make this page purple for 5 seconds, and then make it yellow for 2 seconds. I don't have to actually tell it, the underlying code to do that. So programming seems like it's very complicated, and in some ways it is, but behind the scenes, it is way, way more complex than what you ever have to worry about. So what you get, we're all lucky, we get to, as web developers, deal with pretty high-level stuff. We get to deal with things like writing code that says, when you click on this, go save this to the database. We don't actually have to write the code that tells our computer what a database is. We don't have to write the code that installs things on our machine. We don't have to write ones and zeros or hexadecimal or assembly or machine code. We don't have to write these very low-level things. We get to write things that make more sense to humans. And so that's the important thing as we go through today. Think about, what programming really is. And there's a whole bunch of definitions, but at its core, there is a language to whatever you're doing. If it's making a recipe, there is a language that goes along with creating recipes. If you are making, you're a professor and you're making a sandwich, or you're a robot making a sandwich, there's a language that goes along with making a sandwich, like put peanut butter on the bread. You don't have to explain step by step what that is. There's a specific language, and most people know you take a knife, put in the peanut butter, to spread it on the bread. Same thing with programming. So there's a bunch of different languages out there, all sorts of, human languages, and there's tons and tons of them. Sadly, lots of them are dying off, but all sorts of them, and most of them have things in common. There's different systems. We've got character-based languages, we've got Romance languages and Germanic languages and whatever else. There's families of them, but they all do a similar thing. They allow us to communicate to one another. Same thing with programming languages.
First off, that's a great story with the peanut butter. I studied finance, so I'm going to steal that and think of some finance analogy, and it's not going to work. But that was really well said. There are a ton of languages out there, and as you look at other boot camps or as you read articles online, you're going to see all these different tutorials in all these different languages. So, of course, the first question comes to mind, well, which one do I pick? And a lot of that has to do with what you want to build. So obviously right here you see a ton of different languages. But maybe the first place you look is, okay, well, what do people actually use in the real world? And you can see right here, Python is incredibly popular. And granted, this is not necessarily for web development only, but you can see things like JavaScript and Ruby and Java and C++. So maybe that's the first place you start. You take that entire bubble of languages, turn it into a smaller bubble, and start thinking about which one you pick. And you can read which ones are more beginner-friendly and which ones are more popular and what are the largest sites in the world built off of. But essentially, it's a good combination of a lot of these big ones. And that's really where a lot of the curriculum that we have comes from as well. So data science in particular focuses on Python. We focus tremendously on Ruby. And even though it's at 5.2% right now, JavaScript is growing incredibly quickly. We're going to talk about front end. We're going to talk about back end. And I'm sure if you've read or researched anything about programming languages, you hear that JavaScript is kind of the best thing in the world. So it's something we teach heavily. It's something that's growing and becoming more popular. That's kind of where we derive what we want to teach. But just know that most of these languages, you can accomplish the same thing, but some of them are just a little bit more specialized. So right, why so many? Ease of use, intended audience. There's a wonderful language called Scratch, which is what Harvard CS50 teaches, and it's meant for people who have zero experience with programming. It's even meant for kids between, I think, the age of like 6 and 13 or so. And it's a really wonderful, simple way to learn how to program. You might not build Facebook with it, but it's a great place to start. There are a number of instructions, absolutely with all the languages. Speed is another thing. We're going to talk about high-level and lower-level languages. Some languages are close to what machines understand, which are zeros and ones, or binary. There are also some languages that are very far from that, which are much easier for humans to read and write. So you kind of take that trade-off there. We can talk about that plenty. There are also domain-specific languages. So some operating systems only use certain languages to be built off of, or Windows has its own technology, Mac has its own technology, and so on and so forth. I'm sure you've seen with mobile development, there's Android and there's iOS, domain-specific languages, certain languages for certain platforms.
So this is just, I guess it's kind of hard to read this chart up there, but we'll send out the slides. You can take a look at this link. Basically, this is a chart, a family tree of programming languages. And as you can see, there's a lot of them on there. I think the color coding is, ones that are green are still, let's see, they're still active, so thousands of users. Ones that are yellow are protected, which basically means that not many people are using them outside of academia or universities. So there's a lot of these older computers, some of these languages that have been around for a long time that are still in use because a university has a system or a machine that supports it that's 20 or 30 years old. But not many new people are learning all the languages here that are in yellow or orange. Then in red, there's endangered, which means the usage is dropping off. And then there's extinct languages that are in black. So this is just a subset. These are a lot of the most popular and most famous languages. Basically, it goes all the way back to the beginning. At the very top left, a language called Fortran, that green one up there. Go ahead. Do you have a question? Basic. So basic is on here, but it's actually a little further up. But what I wanted to show you is that there's all of these lines connecting them. They are very, very interconnected, and they're really similar in a lot of ways. So when you're starting out, I remember when I was starting out, one of the most confusing and scariest things was when you take a look at this right here. Where do you start? There is no clear starting point. Everyone you talk to says something different. You know, there may be clear winners like JavaScript or Ruby or start with HTML and CSS, but everyone's going to tell you something slightly different. And it's a little bit intimidating. The real answer, and this is probably not what I wanted to hear when I was starting, maybe not what you want to hear, but the real answer is that it doesn't really matter. Because all of them are so similar. Yes, they have a few different things. Some of them make things easier on you, and some of them may make something faster, but you have to type a little more code. But conceptually, they're almost identical. It's just a matter of syntax. So it's sort of like, suppose you didn't know how to speak any language at all. You grew up in, I don't know, with a pack of wolves, and you were never taught how to speak any language. And you had to learn your first language, and you start to, and this analogy falls apart a little bit when we start talking about other types of languages, like character-based languages, but let's just assume you learn English. And you learn, parts of speech. You learn about nouns and verbs, you learn how to construct sentences, and you learn, things have words attached to them. You learn those concepts. That carries over when you learn French, or when you learn Spanish. So it's just a matter of translating, so instead of saying hello, I say bonjour, or hola, or whatever it is. But you have that space in your brain already that knows this is like the word hello, this is what it is. Now how do I say it in another language? So it's just like that when you start to learn how to program. You learn your first language, and it's going to be a little rocky probably, but once you have that down, you can move and you can translate to any other language really quickly. So developers have some skill. If there's people out there, like Ellie loves Postgres, loves JavaScript, and he can write any language out there, but he has his thing that he enjoys, and all of us do. But that doesn't mean that you're stuck working as a JavaScript developer for the rest of your life. Or if you take this class or any other class that teaches you Ruby and JavaScript, that doesn't mean that you have to apply for Ruby and JavaScript jobs. We have people working in Python. We have people working in Objective-C and Swift. I think that's pretty much it, just because those are the most popular languages now. But you should be able to go and do whatever you want in programming. So it's very, very intimidating when you look at a chart like this. But what's also nice is that it shows you there's a lot of incest here. There's a lot of things that are attached to one another. This is not a nice, one-way, family tree. There's all sorts of connections and cross-pollination, but everything is really similar. So this is the big secret, I guess, is that most developers really only know a few.
Move on. Okay. All right. You saw nothing. All right. Yes.
So really, I would say out of most developers that I know, they maybe are familiar with 2 or 3 languages really, really well, and then they might know 5 or 6 that they've read a book on, or that they've watched a video on, or seen a talk on, and they could probably write, they know the equivalent of how to say hello and thank you in Chinese and Japanese, but they can't actually speak the whole language. The difference is when you're, going to a foreign country and you don't know the language, you are at a huge disadvantage. And it's not like you can just go around and quickly look things up and naturally speak the language. In programming, that's really all that you do. It's all about knowing where is the guidebook for JavaScript, or where is the translator for Ruby. And once you have that and you know, okay, it's on Google, or it's on Stack Overflow, or it's on the docs, the documentation for Ruby or JavaScript, translating is a really quick thing. It's not like you have to type something and you actually manually translate it, like you would with Google Translate from English to Spanish. If you know how to write a program in JavaScript and you want to write it in Ruby or you want to write it in Python, you just open up documentation for Python. I'll show you what that looks like. And you just go through and you figure out, I'm going to say some words that may not make sense, but how do I write a loop in Python? Or how do I create an array in Python? And those are terms and things that exist in pretty much every language. And so it's just a matter of figuring out how you do it in each one. So most developers really only know 1 or 2, maybe 3 tops, very well. And then they're familiar with things called frameworks, libraries, other technologies that are smaller. They're not quite an entire language. So we'll hit on that in a little bit. But the key thing is you need to let go of the idea of knowing every single part of web development. I wish that I knew more about so many languages. Right now, I think the other thing is developers are constantly learning. In their spare time, whether it's on the job, lots of companies pay for corporate training. They pay for companies to come and teach Scala or teach Agile methodology or whatever it is, Git or different technologies that maybe not all developers at a company know. So it's a process of constantly learning, but it's also side projects at home on your own. Every developer I know goes home, and it's not like they just get home and start working immediately, but they have some side project. They're working on something, they're learning some other language that might be something from the 1980s that nobody uses and they're just fascinated in, or it might be the next cutting edge thing coming out of Google. But people are, in general, this is a generalization, but developers are curious people who are always going to be learning something and teaching themselves. So, this is an important slide. Let Ellie take it.
Yes. All right. What can I build? So I think we spoke about all these different languages and all these different things that you can build with these different languages, specifically the domain specific. So what we focus on as web developers are definitely kind of this first half, so right up here and right here. And when we talk about websites, we're talking about what are called static sites, which means that there isn't a lot changing as you go from page to page. When you talk about web apps, we're talking about things that are far more dynamic. And that's where we introduce the concept of a backend and databases and APIs, which we'll talk about a bit later. But the main focus of web developers is to build web applications. And those are things like Facebook and Yelp and Gmail, pretty much everything you use on a daily basis on your computer that is found on the internet, for the most part. Things like native apps, that's where you have only a specific language to build something for a specific platform. So you build Angry Birds for an iPhone, and then you build Angry Birds for an Android, and then you build it for a Windows phone. Those are native or specific to those platforms. That's what we mean by native apps. And then obviously other stuff, I can't build robots, but I'm sure there's a really cool boot camp that would teach me how to do that, so I'll check that out. But there are also plenty of other things you can build too. But the focus of web developers is just building web applications. And what we start teaching is starting with websites. Building a site for a restaurant, building a site for, your parents' favorite hobby or whatever that may be. Something really simple, something fun, something you can share with people, but there isn't a ton of functionality and dynamic nature to it. Things aren't changing rapidly. You don't have people logging into your site and saving information and securing information. That's where we enter the realm of web apps and backend, which we'll talk about.
So as Ellie mentioned, there's this big distinction between static and dynamic websites, or websites and web applications. So I think a restaurant website is probably the most common. If you think of, I have a Yeah, so here's the website for NOPA. This is not dynamic. It doesn't react to who you are. You don't log in. There's no database connected to this. There's nothing that really is dynamic about it. If NOPA wants to change this photo right here of this custard French toast, whoever is the admin here, whoever created this site, has to manually go into the HTML and change that image. So it's not going to change automatically. There's no database connected. There's no code that says every 20 minutes go get a new image from our database, or let a user log in. It's very much like a newspaper, or a magazine, where the developer decides what it's going to look like, what the layout is, and then it just sends it off. And it's not going to change once it's sent off. That's it. So it's not dynamic. There is no insert username here, or insert list of friends like they're on Facebook or in Gmail. When you log in to Reddit, for instance, or even when you don't log in, if we just take a look at the way Reddit works, if you're familiar with Reddit, yes, you'll know what this is. If you're not familiar with Reddit, you're probably very lucky and very productive. But basically, my students are going to kill me. I used that joke 2 days ago, so sorry about that, guys. But basically, Reddit is a site that allows people to post links and mini blog posts or content, and people can vote up and down. And the important part is, it's always risky putting Reddit on the screen. And there's a little bit, some inappropriate stuff. I apologize for that. But what it allows you to do is post stuff. And so it's not a newspaper. It doesn't just go out as, here's today's issue, and it doesn't change at all. It doesn't go to subscribers or to, every time I visit this, it changes. Pretty much every time you reload the page, those posts are in a different order. If you check in the morning and then you check in the afternoon, all of the stuff that happened in the morning is probably further down. And all of the new interesting news stories or whatever events have happened or ridiculous jokes or videos are going to be up top. And it responds to users. And there's a database it's hooked up to. There's dynamic content where instead of just saying the first result or the first thing on the page is always going to say, let's pick one that doesn't have profanity. Physics is cool. And it's going to have this image of physics or whatever this is. That is dynamic. So the code instead says, find the third most popular thing and put it here, whatever it is. Rather than saying, write the words physics is cool. It's kind of like an insert here. We'll talk about it, but this is a really important concept, and there's a key difference. So other types of dynamic websites, pretty much every startup out there at all, if they have a web app or any sort of website, it's actually going to be a web application. So Facebook, Gmail, that's a really important one. When you log into Gmail, you see your emails. You send your emails. You don't just get a blank page that's just here's a bunch of emails that don't change. And you can interact with it. That's the point. You can send information and talk to people. So it also changes based off of who you are. When I log into Facebook, I see a different thing than when all of you log into Facebook. We might have some overlap, but it's all different and unique to us. So these dynamic websites, they change based off of who you are and what you do. And generally they're built with the language like Ruby or Python, JavaScript. They're built with pretty much any language out there really, but these are the three most common. Also, you could use Java, any of those languages really on that chart that I showed a few pages back. Some of them are going to be much easier, some of them are going to be much harder, but these are the three most common right now to build web applications. To build a website or a static page, the newspaper analogy, just to have a restaurant site like this, you can just use HTML and CSS. So we'll go into that in a little bit, but that's an important distinction. HTML and CSS is just what is on the page. What does it look like? That's it. It's the nouns and the adjectives. So put a big text that says NOPA and change the font and make it black and give a wood background on the sides of the page, and we're just describing what needs to show up and how it needs to look. With JavaScript or Ruby or Python or what other languages we use, we're not just describing how things should look anymore. We're actually creating that dynamic content. We're basically saying, insert the top photo or the top pictures over here, insert your list of friends over here, go to the database and get the current username and your profile picture and display it up in the top corner. And we're kind of creating like a Mad Lib almost, where we're not describing exactly what goes there. We're generalizing and we're saying in Ruby or in JavaScript, hello, welcome to my site, or thank you for coming back. and then inserting a username. And that is going to be different depending on who you are. So we use languages like Ruby or JavaScript to do that. So mobile, this fits in there as well. A lot of times I get questions about the difference between mobile websites and mobile web apps, and then mobile apps. And then how does that relate to when I view a website on my phone? On my PC or Mac. So when I go to the New Yorker on my phone, it looks a lot different than when I go to the New Yorker on my computer or my iPad or whatever I'm browsing, my Kindle or whatever device. But if I go into Safari or to whatever browser I'm using, I'm viewing a website. So this is still a website or a web application. What I mean is that it is not a native app. So Ellie talked about how you can have native apps for Android or for iPhone or for Windows Phone. I think Kindle even has apps now. What that means is basically you have to go to an app store to download it. Or you go to whatever the Android store is, or the app store on your Mac, or the app store on your iPad, and you download an app. And that application does not run in a browser. You don't have to open Safari and go to a URL. You don't have to open Internet Explorer. It runs natively on your machine. So when we go to a website on our phone, like thenewyorker.com, it looks different, but that's really just down to how it's styled. So it's the same content, usually just shrunk down. There's a few rules for what works better on a phone. So, bigger buttons, less, don't have as much content crammed into one screen, more vertical layouts rather than horizontal. You'll notice, is my mouse up there? Yeah, so this type of thing shows up a lot for a menu. Instead of having a nav bar all the way across, you would click on this and you get a list of options. So there's different types, of strategies for designing for a phone. But what's important is that this is just another website. It's another web application. This is not anything special. So when you make a website for NOPA, I go to that same site on my phone. It might look bad if the developers didn't plan for someone to view it on their phone, but it's no different than when I go to it on my iPad or on my whatever, even an iPod Touch or whatever you use. If you can go in a browser, you can visit a website.
All right, on to web development.
Yeah, how long have we had? Let's just finish this video up.
Yeah, let's do that. Cool. So I want to show you guys a quick video of how the internet works, because we could try to explain it, but the wonderful people at World SciFest do a much better job.
Is the audio? All right.
Have you ever wondered what happens when someone in England visits the World Science Festival's webpage? First, their computer needs to ask the World Science Festival server for a copy of that webpage. The computer sticks this request into a virtual envelope called a packet, wrapped with specific information about that request, including the World Science Festival's IP address. The computer sends this packet out of the house and below the street via large underground copper wires. It passes through small regional networks before ending up here at Telehouse North in London. Telehouse North is England's main internet hub. The IP address on this packet tells the hub that the World Science Festival server is actually in Los Angeles. So Telehouse North sends the packet out as light across the Atlantic, over fiber optic cables buried deep beneath the ocean. The packet ends up here, 60 Hudson Street, New York City, the largest internet hub on the East Coast. This hub sends the packet through a series of regional networks connecting New York to Los Angeles, where the World Science Festival server resides. The server reads the request and gets ready to send the web page to England. But web pages made up of images and text are too large to send as a single packet of data. So how do we get it back to England? Imagine a group of 5,000 tourists visiting New York City in a single gigantic tour bus. They are way up in Harlem, but they want to visit the Statue of Liberty before it closes. But it's rush hour on a Friday. There's no way that giant bus is going to fit through those crazy congested streets. So they decide to get off the bus and spread out. Some take the subway, some take cabs, a few rent bikes, and some even take kayaks down the Hudson River. How they get there doesn't matter, as long as they get there on time. Likewise, for the internet to work efficiently, this web page is pulverized into thousands of tiny packets of data, each one wrapped with all of the information it needs to rebuild itself in England. The packets are sent to LA's One Wilshire hub, which checks the traffic reports before sending them on. Through Through miles and miles of land they travel, checking in through different hubs. Like our New York City tourists, those packets don't care how they get there, as long as they get there as fast as possible. Most of them will go through 60 Hudson in New York, where they are redirected back to England as light, riding a fiber of glass as thick as a silver dollar. Then back on copper wire through regional British networks until all the packets reach their destination and this epic journey, it all happens in about a second, along with trillions upon trillions of similar journeys that happen each and every day on this remarkable, easy to take for granted network of networks we call the Internet.
All right, so we're going to take a break in just a moment, but that's a little scary. Let's.
It's not my computer. Not my computer.
So let's just recap a few of those things. So,
Hey, 42 here. The internet is big, really big.
so there's a lot of stuff in that video, and the point of that was not to show you, was not to introduce you to IP and to packets and to DNS and servers. Really, it was more to show you the general idea. And one of those big takeaways is there's a lot of stuff we take for granted when we load a web page. That journey is pretty crazy. I think it's one of the things actually deserving of the word epic. Definitely overused. But in this case, when loading one page is millions and millions of these tiny pieces of data sent as pulses of light over a tiny cable buried underneath you. It's pretty insane. And so you don't actually have to know about that. You don't have to worry about that to be a web developer, to make websites. That's all taken care of for you. So that's what I was talking about when someone else has laid the groundwork. All that you have to do is say, I want it to look like this, and I want it to hook up to this database, and when the user goes to youtube.com, it should show them the YouTube homepage. And everything else is taken care of. Someone else worries about how does it actually get into ones and zeros? How is it actually sent as pulses of light across a cable? How does my computer take pulses of light and ones and zeros and turn them into code that makes sense? How does it display it in the browser? You don't have to care about that. But it's good to know how it works. It's good to know that when I go to a web page, I have a quick example here. Let's act this out, Ellie. So if I go to yahoo.com/news, I don't know why I would ever do that, really. I just don't think they, have the best news. So, but if I did go to yahoo.com/news, having a weird day or something, I hit enter in my browser. Hopefully I don't have it bookmarked, but if I did, I could click on the bookmark. And as I click there, that sends something called a request. So the real takeaway is this idea of a request and a response, the request and response cycle. So I ask, if Ellie is the server over here, I'm going to say, Ellie, can you tell me what's on yahoo.com/news? And when I say that, I'm actually sending all these pulses of light across millions of miles of cable, most likely, not millions, thousands of miles of cable, and it's traveling at the speed of light. And Ellie is a server, and he gets my request. I'm asking for yahoo.com/news.
And I send it back to you.
All right.
Well,
so
I'd probably tell you first, why do you want to see this? Because you
yes.
don't like Yahoo.
All right.
But,
so Ellie's going to send me
it
something back. And how does it get sent back to me?
The same exact way.
So just a bunch of pulses of light and ones and zeros. It's not sent as like this completed thing. So if you remember in that video, there was this one scene where this web page was broken down into these tiny little things called packets. Not important that they're called packets, but it is important that a web page is not just sent as like a completed web page. It's not sent as like a book that you get already ready to go. It is sent at a very, very low level. Ones and zeros, that's it, light on and off. And it's sent from the server to me, and then my machine gets that and it makes sense of it. So my machine, the point of my web browser is to take that information and turn it into this. So this is something that happens nonstop. Every time I open up Facebook, every time I post a comment on Facebook, upload a photo, I check my email, anytime I get a new email and it just pops up in my inbox, anytime I check the news, whatever it is, there's a request being sent and a response coming back. So this is a cycle. I ask for something, it goes all the way to a server somewhere, and that server sends me something back, and I display it or I do something with it. Oftentimes it happens so quickly it doesn't really look like anything happened. But every time you open a link, every time you write an email, a request is being sent and a response is coming back. So as I mentioned, browsers take that code and they turn it into something that humans can read and understand. So in this diagram, there's this intermediate step right here, where there's a bunch of code here. Doesn't matter what it is, it's HTML and CSS in this case, but this code doesn't make sense to most humans. You can't look at this and understand what it looks like or what it's describing. But my browser takes this, and it turns it into this. So the code that I send back is just instructions on what a page should look like. It should be have a blue navbar that says Yahoo, and it should have a photo here and a photo to the left and whatever. There's an ad on the right page, but that is just HTML, and my browser turns it into this. So browsers are like the translator. They take code and they turn it into like a visual interface that humans can look at and understand. So a bunch of browsers out there, some more popular than others. I'd say at this point, Chrome, as far as I know, is the most popular, or out of new browsers. It used to be that Internet Explorer for the longest time was the most popular. Chrome is at least the fastest growing, I do know that. And it's the most popular amongst developers as well.
What's the middle one?
Opera. Yeah, it's never used it, but this is one picture, so it came with the picture. So just to review, a browser takes this kind of stuff and turns it into this. So let's take a break here. Take 5 minutes?
Yeah, sounds good.
All right, I don't know if it's on any single website, whatever it is, you can click on View Page Source, and it shows you the underlying code. So actually, this is an example that is a little bit intimidating. Nobody actually writes this code. This code it's called minification. It's been compressed into a huge block, and the point is that it's supposed to take up as little space as possible. So that's a little bit intimidating. We can take a look at. It's intimidating for us too. I would never. If we take a look at this is some of the same stuff. Here we go. So this is regular HTML. It's still a lot. So it's still intimidating certainly, but it's still plain text. We'll talk about how it works and how you would read this. But the whole job of the browser is to take something like this, which is your computer's way of describing how a website should look, and turn it into this. So this is what, when we talk about request and response, when I say, I hit enter here, that's sending a request to the server saying what is on smashingmagazine.com. This is the address I'm looking for. Send me back whatever you have for smashingmagazine.com. Then the server, it gets that request and it decides what to send me back. So it picks probably the top articles, it picks some ads on the side, and it turns them into an HTML page like this. And then it sends it back to my browser, and my browser takes this and turns it into that. So that's the job of the browser. It's the interpreter. It takes this crazy looking stuff and turns it into a nice, readable human form. So just to review, that was a right click, and then view page source. Where is that? View page source. Or you can also go up somewhere here, I think, to view, developer, view source. So that's in Chrome. Every browser has its own version of that command. I don't know them all by heart, but Chrome, you can also do Command Option J, and it will take you there as well. Okay, so we want to get through this relatively quickly so we can start showing you some code here. Front end versus back end, take it away, Ellie.
Cool, so we'll talk a little bit about front end versus back end. I think there's a good analogy here, but you can think of front end development as everything users experience in their browsers. Everything that you actually see is the front end. And the front end is encompassed of 3 technologies. Any guesses what those are? So we saw one of them before. Feel free to shout it out. It's all good. All right, so HTML is one, CSS, and JavaScript. Excellent. So what do the 3 of those do? Because they all have their purpose. They're all specific technologies. They all serve a certain purpose.
They like deceiving on the website.
All right, so that's one good point. HTML itself is the content, the words on the page, the structure, the semantics of the page. CSS is the styling. It stands for cascading style sheets. But think of the key word there being style. Changing colors, changing font size, making things look different when you change the size of the screen, things like that. You want to fix things on a phone, you want to make things look larger when they're not on a phone. You're going to use CSS to do that. You want to change the font size, the color, once again. When you want to change the behavior of the site, when something is clicked, perform this action. When I move my mouse down, show me an extra 10 pictures. Anything like that is related to JavaScript. And JavaScript, you can write on the front end and back end, but traditionally it was always the front end technology. So 3 technologies that encompass the front end: HTML for the content, CSS for the styling, JavaScript for the dynamic nature or behavior of your site.
So another analogy I think I already mentioned is that HTML can act as the nouns in your sentence or on your page. It is the what. Put a picture here, put a bullet point here, and put a link at the bottom. CSS is the adjective. So put a purple link and a picture here with a border that's 3 pixels of red. And it is the styling, it's the adjectives that describe those nouns that are the HTML. And then JavaScript, depending on who you ask, either the adverbs or the verbs. It's the motion on your site. It's the interactivity. It is what it does. So if HTML is what goes where, CSS is how it looks, and JavaScript is how it behaves. So we'll show you an example of that. Here's a link. I know you can't all visit this. It's not that important for now, but you can revisit it once we send out the slides. Basically, it's a really terrible, ugly website. Yes, we know that. But this is an editor called CodePen. So codepen.io, it lets you type HTML, CSS, and JavaScript in the browser. And you can see right here, I have 3 slots, one for HTML, one for CSS, and one for JavaScript. So this code here is what results in this pane on the right. So this purple My Website stuff is all generated from these 3 boxes. So usually you wouldn't actually write a full website in this. This is not where developers work most of the time. You would actually work in a text editor like you would work in Microsoft Word. We have our own version of Microsoft Word. There's lots of different types for programmers. Things like Sublime Text, Emacs, Vim. There's lots of different software out there that developers use. But you write code on your machine. But CodePen is an easy way to share code. It's an easy way to write it in the browser quickly. And so I can send you this link. I don't have to upload a file. I don't have to put it on Dropbox or use some sort of file sharing. I just send it to you as a link. Also, just a quick side note, you can view other people's CodePens here. So you can take a look at, here's somebody made a guitar scale viewer, and here's all the code for it. And then I can view the scale for C and C sharp. This is just some person made this, and there's thousands and thousands of things that people have made on CodePen that you can play around with. It's a great way to learn and to find out some really exciting things you can do. Okay, so what I want to show you though, let's take away all of this. So no CSS, no JavaScript, just HTML. Avoid focusing on the syntax as much as you can. We're not going to go over line by line what this does. But please think about conceptually how it works. So we said that HTML is like the nouns. It's the what on the page. So here I'm saying, make an H1 that says my website. And an H1 is a heading. So make a large heading that says my website. And that's what I'm getting right here. Make a button with the text, click me. And that's what I get here. It doesn't do anything because I haven't written JavaScript to tell it what to do. So it's just the what. I've got a paragraph that says list of my favorite things. I've got an unordered list with Octocats, Ruby, and learning to code, and that results in 3 bullet points. So basically, the trend here is you just describe what you want, you fill in a few blanks, whatever you put inside of here. So if I change this to say, hello class, over here, I get hello class. So this is HTML is actually really simple to start with. There's no complicated logic, there's no math, it's just you describing what you want, and the computer takes care of the rest. The browser does it for you. So on its own, it's not very exciting. So down here is how you make an image. You can focus on that on your own time, but basically you just take a link for an image and you put it inside of an image tag, and it takes care of it. Okay, so that's HTML. Now for CSS and JavaScript.
I think as you're loading that, you can see kind of the key pattern in everything that you're doing in HTML. Almost everything has a closing tag, but everything's going to start with some kind of tag. I want a heading, I want a list item, I want a title, I want a button. Everything is inside of a tag. So we call these button tags. Essentially, this is a button tag, sorry. You have an H1 tag above that. So when you think of HTML, you can think of tags as the way of structuring your code. Something goes inside of some tag, some other information goes inside of the tags themselves. So anytime you see code like this, you think to yourself, okay, that's HTML, that's what those tags are. This is just an H1 here, you can make that an H2.
So it's as simple as just, there's a very finite number of tags you can read about online. There's about 50 or so at this point. and you just find which ones you want to use. Do I want a bullet point? Do I want a link? Do I want an image? Do I want big text? Do I want a paragraph? Whatever it is, italicized text, you just describe what you want, and then you fill it in with what content needs to go there. But on its own, it's not very exciting. So CSS is what allows us to describe how it should look, not how it should behave, just how it should look. So if I add the CSS back in, it's very ugly, but now I'm starting to style it. So what I'm saying is go find something called the body. It doesn't really matter here, but make it have a background color of purple and make the text color white. Go find all the links and give them a color of yellow. So that's how we end up with this link down here. But I can also do things like go find all the images and make them be 100 pixels wide. And then I get a much smaller image. Or I can say give it a border of 20 pixels of solid pink. It's going to be hideous, but now I have a solid pink border around that image. So it's just a matter of finding a noun, so image in this case, and then describing something, giving an adjective. Make it 100 pixels wide. Make it have a border that's pink and solid. I could change all sorts of properties on the page just with CSS. So that's HTML and CSS. Again, I see a lot of puzzled faces. This is not an overview of, or it's not an in-depth analysis of it. HTML and CSS is something I just keep open the CSS reference online, and every time, I always have to remember, how do I make something move to the right, or how do I make something, what are the different properties for the border? It's too much to know. There's thousands of different things in CSS. So it's just a matter of knowing how to find it out online. So it's really not about having it all in your head.
I think I just want to just add one little thing. When you start looking at this, the first thing you think is, okay, what the hell is going on here? But when you think about it pretty logically, IMG is what? Or A is what? What do we just call those things? In our HTML, what were those? Those are tags. So I'm telling my CSS, hey, find all the IMGs, find those tags, and then give it a width. Give it a width of what? The value, 100 pixels. So when you look at CSS, it's actually very readable. And at first it looks very intimidating. There's this border and a width and color and all these properties and all these values. But it's something that you can really learn quickly just by taking it step by step and taking a look and just trying to think, okay, what's going on here? I made this yellow, but how did I make it yellow? First, I had to find it. We call these selectors. So select the anchor tag, select any A tag, and give it a color of yellow. It's actually very readable when you think about it. And the best part about some of this stuff, especially with HTML and CSS, it's plain English. You can take a step back, you can read it very quickly. And the JavaScript that Colt is going to show you, that's where it starts to get a little bit more complex. That's why we spend months and months, or people spend careers learning the language.
Right. And I think HTML and CSS, Elliot would probably agree, is a great place to start. It's quick, it's immediate and visual. You can make all sorts of great websites, not web applications, so you can't make Facebook without a language like JavaScript or some other back-end language. But you can make a personal site, a portfolio site, a marketing site. You don't necessarily need JavaScript. Just to show you a really quick website, it's called CSS Zen Garden. And this is a great illustration of the power of CSS. So the whole idea here is that everybody starts with the same HTML file. And this is the base HTML. No styling. Remember, HTML is just plain, ugly, there's no adjectives, just the nouns. So everybody starts with this, and they write their own styles. So just like we turned this purple, somebody could come along and turn it red instead. But instead of just changing the colors, what CSS Zen Garden allows you to do and asks for people to do is come up with radically different designs. So here, here's a few. There's hundreds of different designs on here, but there's some pretty fun ones. It's the exact same HTML, the same content, the same text, styled differently. So we started here, and just with one CSS style sheet, so one file of those CSS lines, we can end up with this, or the same HTML can end up with this. And once again, the same exact HTML. Oh, this one's a little buggy here. I think it's the display on the projector. There's a cool animation, it usually does. Or this one here. So this is all the exact same nouns underlying. It's the same skeleton, just different skin on it. So there's lots and lots of them here. I recommend, this is my favorite actually. It's a nice little robot that pops up. So all CSS. So I think that's a really good resource just to see the power of it. But by all means, I don't know if I could create some of those. the CSS is its own very complex. It's not complex, but to get good at it and to make beautiful sites, it's more than just understanding CSS. You have to be a really good designer, which I am definitely not. So we'll talk about the workflow, but at most companies, designers and developers are separate. The designer tells you what it should look like, and then a developer goes and implements it. So I don't have to come up with like the layout of my page. I get a Photoshop image or a wireframe that shows me how it should look, and then my job is to make the website look that way. Some of you might be lucky enough that you're already designers or that you have a good sense of design. Most developers probably don't. So the last category here is the JavaScript. And JavaScript adds in the ability for our code or for our website to react to us. And this is a really, really simple example. I'd like for you to take a look at this. There's a lot of foreign stuff and crazy syntax you probably haven't seen. Some of you may be familiar with it. But take a look at this 3 lines right here and try and guess what it does. So most of you, I'm guessing, haven't seen this before. But if you take a look, go line by line, think about how the CSS works. We pick something, a body, an anchor tag, an IMG tag, and then we did something to it, like change the color or change the width of the border. This is not all that different. Does anyone want to shout out what this does? What you think it does? Go ahead.
I think it makes it so that when you click the button, it turns the background color yellow.
Exactly. So that's all that it does. It's a lot of words to do that, and some weird things, these $signs, parentheses, the quotes, function, curly braces. It's kind of some syntax you have to get over. But at the end of the day, what it's saying is when the button is clicked, so that's what this does, when the button is clicked, do all of this. So whatever is inside of here, do it. And in this case, we're saying change the background color to yellow on the body. So when I click, background color changes to yellow. So not the most exciting site. But this is underlying every single thing. When you click on a web page, you click on compose email in Gmail. When you click on upload photo on Facebook or comment, or you click on the like button on Reddit or on Facebook, behind the scenes, something like this is happening. Something is saying, when this is clicked on, do this. When you click on the upload photo button, whatever happens, there's some complex logic, but something happens when you click. And that is the JavaScript. So we could spend we spend, 6-7 weeks on JavaScript. So we could spend a long time on it. But what I really want you to take away is just that it allows you to make things interactive. So it's not just clicking. It's everything from events like dragging and drawing and hovering and different effects, animations, playing audio, doing 3D graphics, creating games in the browser. There's a lot of things that JavaScript allows you to do. And I actually have a few links here that are really fun to check out. I recommend you check these out on your own, but this is one that I really like. I'll let it go for just a second. So this is all JavaScript. Just what we saw, HTML and CSS plus JavaScript, just combined in a really interesting way. And this is really complicated to write the code, but it's just JavaScript. So it's an interactive music video. It's an Ellie Goulding song, and it's 3D graphics. And I can control this with my mouse. So this is all JavaScript, which it's crazy stuff. It really is. But there's, I don't want you to think it's just to make buttons change colors. It's not just to change the color of a background from red to yellow when you click. But it is, in this case, when I click and I drag to the left, this little golden thing should move to the left. When I click and drag to the right, it should move to the right. It's the same underlying concepts. When the user does something, change something on the display. Also, that's just really cool. So, all right. I know. It's kind of fun. There's some other really cool stuff here too. I also really recommend taking a look at this one. It's a pretty cool video. You can use your phone, and you basically control the camera of the music video and control effects by using your phone and hooking up to the webcam on your computer. So really interesting, cutting-edge stuff. All right.
I'm really supposed to follow that with back-end development? All right. So back-end development. So the site that you just saw Colt build, there wasn't that much logic there. There wasn't anything that changed each time that we went to the site. When I went there, it didn't say hello Ellie, it just said hello class. If Colt goes there, it doesn't say hello Colt. Nothing changes each time I go to that same page. Nothing is being stored every time I go to that page. If I want to put in some information and I want it to remember me, we have no way of doing that with the code that we saw. We only saw the front end. There was no connection to any kind of back end, or we're going to talk about a database as well. So we talk about back end development, that's kind of the other side of the story. That's what you don't see. But that includes the logic and processing that happens outside on a server instead of the browser, which is what you're experiencing. So with back-end technologies, this is where we talk about technologies like Ruby and Java and Python and PHP and C++ and Scala. There are tons out there. But more importantly, a server's job is to connect to another type of server, which is meant to store all of our data. So there can be lots of different kinds of servers. There can be file servers and email servers and database servers. But when you think of a server, you most likely think of what's called a file server. The server's job is just to give you files or to serve files. That's why we call it a server. The server's job is also to talk to a database where we're going to store our information. So we keep the two of those separate. There are different types of database technologies. There's relational and non-relational. Things like MySQL, Postgres, which I, like Colt said, like very much. Mongo, which is another thing that we teach here. Just all different types of technologies around the concept of how to store and remember information. Some of these are better at other things, some of them are worse at other things. They all kind of have their trade-offs, but it's all around the same idea of remembering things or storing them permanently. So I really like this analogy of the restaurant where we talk about our front end that's encompassed of those three technologies, our HTML, our CSS, and our JavaScript, and that's what the person sees. So imagine you're at a restaurant, you're eating a really nice meal. You have no idea about all the ingredients that went in there. You have no idea how it was made or who prepared it or who saw the recipe or who retrieved a recipe from somewhere. That could be a database maybe. And then someone just brought it to you. Someone just served you that food. That's the server serving you that page. And all you see is the page, which is encompassed of HTML, CSS, and JavaScript. So we talk about the back end, we're talking about different technologies serving a completely different purpose. So I have front-end developers and back-end developers, and full stack, which encompasses the front end and the back end. So that's what full stack is.
So I just want to add one thing. When I mentioned that analogy of Mad Libs, so if you take Facebook, for instance, when it greets you, or any website that says welcome back Colt or welcome back your username, imagine when you go to that site, it sends a request that we talked about to the server, and the server's job is to figure out what am I going to send back, and before it can do that, it has to figure out what is your username. Who is logged in and what is your username? So it's going to go to the database and say, what is this guy's username or this girl's username? All right, it comes back. It is Rusty, which is my dog's name. And we take Rusty and we put Rusty in that HTML so it says, welcome back, Rusty. Or, thank you for signing up, Rusty. Or whatever. And then send that back to the client side where my browser displays it. So anytime we have a database involved, anytime there's like an insert username here, insert top posts, insert friends, photos, whatever it is, that is coming from a database, and that happens on the server side. Are there any questions on any of this? We haven't really paused for questions yet. Okay, there'll be time for questions at the end as well. So frameworks. This is where it gets interesting, definitely, and a little more complicated. So frameworks, at their core, are basically a bunch of code someone else wrote that we can use. So we talked about how developers are always looking for ways to make their life easier. There's no need to reinvent the wheel. So there are lots of things that every website or most websites need to do. So let's take the example of Facebook again. What's a feature that's common across lots of websites? Signing up, user login, authentication. Or another feature might be uploading a picture. That's a pretty common one. Or commenting on something. Or infinite scroll, if you know what that means. Or you can keep scrolling down a page and it keeps loading. There's all sorts of effects, all sorts of these small pieces, and those aren't really considered frameworks. Those are small things you might use. Like I might use Ellie's code that he wrote to do user login. I might write some code and share it with somebody else online. The whole community of being a web developer and that whole ecosystem is built on sharing in a lot of ways and on recycling code and not reinventing the wheel. And one of the big things, so this is different than a small feature like user login or image upload. A framework really is a way bigger idea than just a tiny little feature. So a framework is what it sounds like. It's like the scaffolding for your website. If you're going to make a new website, you don't need to start from scratch. You don't need to figure out, how do I start a server? How do I listen for requests? How do I send back data? How do I connect to a database? All these standard basic things that everyone needs to do to make a web application, frameworks often take care of that. And there's different types. There's front-end frameworks. There's back-end frameworks. So what I talked about, creating a server, connecting to a database, all of that is a back-end framework. So something like Rails does that, or Django, or .NET. What they're concerned with is getting you quickly up and running with a server, getting you quickly connected to a database, finding a way to send back files. Lots of things that somebody wrote that you don't ever need to do. So you could focus on, how do I make my website unique? How do I add the functionality of my website? I don't have to worry about, how do I actually send a file back? How do I create a server? So it's all about not reinventing the wheel. So you can focus on, like, okay, here's my startup. How do I make this social network that does something unique? My dog dating whatever website. And you focus on that, not on, how do I actually get this online? How do I create a server? How do I send back HTML, connect to a database? Then there's front-end frameworks, which are similar, except they don't necessarily do the same things. But they are another tool that we use. So there are things that we do all the time, and it's a little difficult to get into it, but let's take the example of CSS. Some things in CSS you do a lot are position things on a page. And it's actually notoriously difficult to position things exactly on a page with CSS. Unfortunately, you cannot say, put this image at coordinates 350, 62. You cannot position things that way. So there's a lot of struggle that goes into putting things exactly where you want them on a page. So there are frameworks that take care of this for us. There are CSS frameworks that allow us to basically use someone else's code that's going to help us position things. Or there's going to be a framework that has a bunch of buttons and forms and fonts and things that look nice together that we can use. So frameworks are really just things that are helpful to get you started and get you going. So you don't have to reinvent the wheel. You don't have to do the basic groundwork to create your app. You can focus on what makes your app different. Where is the actual functionality of your app? Not what does it have in common with every other website. Because the whole goal of the framework is to take care of that. It's to get you going. It doesn't give you a website that does anything, but it gives you the foundation for a website. So it's a little complex to talk about. There's a lot of different types of frameworks. The most popular, though, and the ones we talk about the most in the class are going to be Rails, one called Express, Node and Express you may have heard of, and then Angular, and we'll also cover Bootstrap in the class. So front-end and back-end, Ruby, JavaScript, CSS, lots of different types. But frameworks are an important concept. So we're actually going to skip past this for a second and we'll come back if we have time at the end. I just want to go over this a little bit more. So stages of web development. We mentioned this a bit earlier. I'll let Ellie talk about it.
Yeah, so usually when you think about development, when you think about development at some tech company, you have designers and you have QA people and you have developers, and where does everybody kind of fit in the process? And that really all depends at the company you work at. So if you're at a very big company, you most likely have people whose sole job is to test code. It's usually what QA, or quality assurance, does. You have developers, that's not too bad, and you have designers who will do the job of designing. But like you saw before, as a developer, you can do all three of these. And we haven't talked about testing too much, but something that's essential when you're building an application is making sure that it works. And it's very easy to just go on the internet and try to break things, but when you're building really sensitive parts of your application, you want to make sure that credit card numbers are secured. You want to make sure that when you send an email, you don't send it 5 times accidentally. That's where you want to write code that actually tests your code. And there are plenty of ways of doing that. We teach a lot of ways to do that. But normally, when you think about building something, there are different ways to go about it. And there are different methodologies of how I should build an application. Some people just like to start coding first, make it work. Then maybe they'll design it, make it look pretty, and don't have enough time to test it. Other times when you're at a larger company, you have a pretty strict procedure. The designers start with it. They hand the designs to the developer. Kind of very Office Space-esque. Like there are people persons and there are developers. But you have designers who hand it off to the developers, who then hand it off to the quality assurance people, who test it all, make sure it all works. I think that's the next one. So, okay, so we talked a little bit more about design.
So we're going to just brush over this. We're not going to, we're not UX designers. I used to teach a class for somebody who had a ton of UX experience, so most of this came from me bugging him. But basically, design is obviously a really important part in how we use websites. When we talk about HTML and CSS, when we write that code, the whole point of it is to create an interface for humans to use. We talked about how the browser translates that ugly text in HTML into a nice thing to look at. Well, that thing has to be designed, it has to look nice, it has to make sense. And there's all sorts of different considerations. I don't want to spend too much time, but big questions like, why are users coming to our site? What are their goals? What do they need? Who are they? Are they students? What kind of knowledge and experience do they have? Are they programmers already? Or are they grandparents who aren't comfortable with computers, really? It really depends a lot. And think about some of the sites that you use and what they're oriented, or who they're oriented towards. So something like Reddit. There's probably some considerations there. You know, it's not maybe the most, first of all, it has a pretty terrible interface to begin with, but it's not the most beginner-friendly website. Or it's not the most accessible website in a lot of ways. It's not kid-friendly. Versus something like, some website, well, it's a terrible example, but, some children's game or like Nickelodeon's website, that is oriented probably towards children, and then there's probably a section that's oriented towards adults, and those are design decisions that are made. But more, less obvious ones, like when are you visiting? In the morning, the evening, when do you go on Facebook, when do you go on Instagram? It really changes on the person, but that data I'm sure is being collected. Depending on where you are, that data is really meaningful. Do people come to my site every time, every day? Or maybe it's a travel agency and I only go on that site when I need to book a flight. Or is it something like Groupon or eBay or whatever, eBay, the only time I ever go to eBay now really is when I'm looking for like cheap computer parts that are not made anymore, but I'm going there distinctly or on purpose when I know what I want to buy. But some other sites, you might just go to browse, like Gilts or One King's Lane or whatever you use. You might just go there to browse things and see if there's any sales or anything you want to buy. And it's two totally different approaches to online shopping. So what are their habits? And how are they accessing the website or accessing the website? Really important. Are you on a tablet? Are you on your phone? Are you on the phone itself, like actually calling in? Are you on a screen reader? Is somebody, some disabled people access the internet through screen readers that actually reads out loud the content of the page. So there's all sorts of different ways of viewing content or listening to content, and you have to consider that. So a really common example is to go back to screen readers. Let's say that you're blind and you cannot see the content on a page. Well, you probably don't want to have a screen reader telling you every single detail of the page, left to right, telling you, you may want that. You may want something that describes all of the colors and how things look, but most of the time screen readers are meant to just give content and to give really the important stuff. So there's a lot of thought that goes behind actually creating an accessible website for people who are disabled, and there's a lot of different techniques and tools that you use, but the key thing is you design sites differently for how people access your site. So think of Bank of America or any banking app. If you visit it on your browser, it's going to be this huge thing with tons and tons of buttons. If you view it on your phone, you go to bankofamerica.com or chase.com, you're going to see probably less information. It's not just going to be a squished down version where everything gets scaled down 50 or 70%. There's going to be sparser stuff. There's going to be buttons spread out. There's going to be buttons that didn't exist before. There's not going to be as much information at once. You're going to have to scroll more. You're going to have to go to different pages. And there's different layouts. So here's a really quick demo, just what I'm talking about. So there's a site I think most of you are probably familiar with called Hipmunk. Oops. Another site called Audioso. So these are both flight searches. Their purpose is to help you plan travel, to buy airfare for the most part. And you can check out, so Hipmunk, you take a look at how it works. I need to know what day I want to fly out, what day I want to return, how many people, what city I'm leaving from, and where I'm landing. I need to know all of that ahead of time. Versus something like Audioso, it does the same thing, except it's way, way different in its execution. So I can say I want to go to anywhere. And I want to go for any time in the month of December for about 2 weeks, or exactly 2 weeks. So let's do about 2 weeks. And let's go from San Francisco. And this is a way different approach. It does the same thing though. It has a database of flights that it's searching, or it goes to a bunch of APIs for flights. but it allows you to search in a different way. So somebody who goes on this site is probably going to have a different goal in mind than somebody who goes on a site like Hipmunk or Expedia or whatever you use, Kayak. So this is about, I kind of like this site because it lets you just kind of explore travel. And you can look for trends. So you can say, I want to go to Iceland sometime in the next year. And it will tell you, all right, well, your cheapest bet is going to be in the off-season in winter. But there's also a surge in prices around the holidays or whatever. It will give you all that data. Versus if you wanted to find that out on Hipmunk, you would have to search for like every week yourself over and over and over and keep incrementing the date week by week. And it wouldn't be very easy. So there's radically different UIs here. The design is way, way different, but conceptually they do pretty much the same thing.
All right, so I'm not going to have you guys walk through this code. I think that's a little bit much. So yeah, someone wants to tell me what's going on line 55. That would be great. I'm kidding. So basically the process of development is taking the ideas that you have and translating it into something like this. So I want to do something when someone presses a key and I want to talk to a database here and I want to get data from this API here. It's essentially the process of development. So once you've thought about what your users are going to do and how they're going to interact with your site, then you can start working on some of that code. And I think what's really cool, what Colt showed was some of the wording on the site where I think Adioso is something like the most flexible way or changing the way that you travel by making it flexible, whereas Hipmunk was the fastest and easiest way. So when you start thinking about, okay, well, some users want fast and easy, some users want flexible. The ones who want flexible need to have the functionality of going anywhere. So I need to build that. So I need to develop that. That's the next step in this phase. I'm going to talk very, very, very briefly about something called version control, because you might hear of a term called Git, and I'm sure a lot of you guys have heard of a company called GitHub. And GitHub is a place where people host their code and share their code and collaborate together. And that uses an underlying technology called Git. And Git is a version control system, a technology that lets us save versions of our code. So as I'm working, I want to stop at a point, I want to save it, kind of take a snapshot of it. Then I want to keep working, take another snapshot. Then I keep working. If that code's terrible, I can find that snapshot and just bring it all back. So that's really one of the biggest ways that developers work together. I don't want to get too bogged down with all the details, but it's essentially a really great way of saving your code in steps. So you can think of if you were working on a screenplay or something, you'd have screenplay V1, screenplay V2, screenplay V3. If you don't like V3, you go back to V2. With code, it's much more difficult to do that, especially when you're working with 15 other people. So imagine if we're all working on the same screenplay. What if you change something and I need to see that? Or Colt changes something that conflicts with something that I've changed. It starts to get very complex quickly, and that's where version control helps us out. The next step that we want to do is actually put our application on the internet. And there are wonderful providers that let us do that. We call that process deployment. Heroku and Amazon Web Services are probably two of the biggest ones that will do that for us, and we talk about that kind of ad nauseum in class. But this is when you get past the point of writing code on your computer and you want to share it with the world. You have to put it on the internet, and that's where these providers will help you greatly. The last step is testing, and there are lots of different ways, like we said, of testing our code. You could have a manual QA where someone sits down and clicks through everything and documents every little thing and says, I tried this went wrong, this didn't work. That gets very tedious. It's also very expensive. You need a lot of people to do that for a big application. So what if you could write code that would test instead of worrying about a person trying to figure out every possible permutation or way of accessing your application? We call those unit tests. That's where you write code to test your code. You write code that checks other code, essentially. The last one you can do is automated testing. So if you write code that checks other code, that might not be that focused on the behavior. So there are different types of tests you can run to do things like, when I send out 5 emails, make sure it's 5 emails. Versus tests of, when I click on this button, let's make sure that the user goes to this page. And then when the user clicks on this button on the next page, go to this next process. So lots of different kinds of testing and lots of different ways to do it.
All right, so one of the big, most exciting topics in the class is when we get to APIs. So APIs, you've probably heard the term thrown around quite a bit. It stands for Application Programming Interface. And what that really means is, if our HTML is an interface for humans to view a web page or to view data, if that's what HTML is, the browser renders a nice page that I can look at, or this is a nice page that you can look at. Hopefully it's not the best design, but it's at least geared towards people to view with eyes and to look at. We write code, though, that often relies on, my students this week were making a code that used some Facebook data, or it used tweet data. And they're not gonna like go to the Twitter website and have their code like use eyes to view like the top 10 tweets and use their eyes to like type something in the search box and hit enter. Instead, there's an API, an application programming interface, that is made for code to get the Twitter data, or for other code to get the Facebook data, or the weather data, or Fandango ticket prices, whatever it is. The idea is that I can write code, and I can say, go to the Twitter API and get all the tweets that mention Rusty the dog in San Francisco. And then I will get data back, and it's not going to be made for computers to look at. It's not going to be made for humans to look at. It is made for computers and code to look at. So basically what it means, and here's a predictable way for applications to communicate between one another. So it's an interface for computers rather than humans. So really important, because this is how we end up with like a website where you log in through Twitter, or you log in through Gmail or Facebook. Or it's how we end up with some other stuff.
Google Maps.
Yes, Google Maps, sure. You have Google Maps on pretty much every site nowadays has some form of map on it. And they're not all writing their own map code. That's all Google Maps code or Mapbox or Leaflet or some other map technologies out there, but they have an API that is shared across multiple computers. So here's a few examples. Twitter, Facebook, Twilio, so that's a pretty cool one. They're based around here. Twilio allows you to write code that will actually send text messages or make phone calls. You can set up a call center using Twilio. So you can make an app, for instance, like going back to Bank of America, because I love them so much, they're so great. You can go into Bank of America and you sign up and they ask you to do two-factor authentication, where they ask you to type in a code that they text you. So they text you a code, a 4-digit code usually, and you have to type it in on the website, and then they have to match in order for you to be authenticated. That is using Twilio, or it could be done with Twilio. So Twilio is just a way that you can use code to send a text message, which is pretty cool. You can use code to make a phone call. You can actually use code to write something that will call somebody on their birthday and then sing them, a robot voice will sing them happy birthday. And you can do that all with just simple code. Spotify as well as an API, iTunes, pretty much every big service and startup out there has some form of API. Some of them are free and public, some of them you have to pay for. So just a quick example here. Let's take a look at imdb.com, so Internet Movie Database. And let's take a look at, what did I see recently? Mad Max. And this is an interface very much designed for human eyes. Like, this does not really make sense to a computer. There's a lot of stuff happening. There's animations, all these colors, a lot of space is taken up. But if you condensed all the information on this page, it really wouldn't be all that much. Aside from the photos and the fonts and the colors, just like the title, the rating, summary, director, writer, that's just a few bits of text. That's what's in the database, and that's just being displayed nicely to me. So if I wanted to make a website that was going to show all of the information about movies that are currently in theaters, for instance, the top 10 movies in the box office, I don't want to have to wade through all of this stuff to get the title and the year and the rating. So I would use an API. So IMDb actually doesn't have a free API. So I'm going to show you OMDB, which is Open Movie Database, which is just all the data from here that somebody took and turned into a free API. So I don't want you to focus too much on what I'm doing here, but here is the API version. Notice that it's the same data: title, year, rating, runtime, genre, director, writer, actors, plot, and so on, score, IMDb rating, awards, the poster image. Oh, well, maybe not. But it's all of the content from that page, just stripped of anything that's made for humans, stripped of all the colors. It's just basically those fill in the blanks I talked about, the Mad Libs. It's just the title, the year, and all of that stuff. So this page gets turned into this. And so my computer can use this way, way, way easier than this. Because I don't have to write code that says, ignore all of this, ignore this, and this, and this, don't touch this, get rid of all these colors, get rid of the fonts, find this star, and then take the number inside the star. I can write code that just says, go down to where it says IMDb rating, and take that number. It's much easier. So that's the simplest concept of an API, is that it's just a computer interface for data. It's not an interface for humans. All right, so we're pretty much done with like the lecture part here. I do want to open it up to questions. Before we do that, I want to talk a little bit about things that you can do going on from here. So there's, as I mentioned, like a million things that you can do with web development, and it's really intimidating when you're starting out. If you go back to that slide with like 20 or 30 different languages and technologies, we probably mentioned like 100 plus different frameworks, libraries, languages, technologies, tools, and terms you may or may not have heard of. And a lot of them are kind of just buzzwords around here now, especially in the Bay Area. All these new things pop up all the time. A lot of them here have events at Galvanize as well. So there's always some new big thing. But at its core, there are a few things that we recommend certainly that you start with. So some of those steps, before we talk about the classes here, some of those steps I would really mention are going to be HTML, CSS, and JavaScript. If I was going to start over learning, I would absolutely start with HTML, CSS, and JavaScript. And the reason for that, we mentioned HTML and CSS and JavaScript are really like the trio, the trifecta of front-end development. However, recently, JavaScript has also started to emerge as a back-end language. So if you learn JavaScript and make front-end sites, or you make client-side applications, you can pretty quickly translate and start working on back-end web applications or full-stack applications using that same language. So you don't have to learn Ruby on top of JavaScript. You don't have to learn Python on top of JavaScript. That doesn't mean that JavaScript is the answer to everything. There are still very specific situations where JavaScript is going to be worse or JavaScript is going to be better than something, but it still is going to get you started. And it's by far the fastest growing language out there right now. So those are our recommendations as far as technologies. As far as next steps on how you would go about doing that. If you're someone who thinks HTML and CSS is really interesting, you want to make portfolio sites or sample sites, marketing sites, start there. There are great books on design. There are great books in HTML and CSS, free online books, tutorials on YouTube, things like Code School. Go on CodePen. Find all of those great, already made resources. People make really interesting things on CodePen. You can start there. If you're someone that maybe you know right now that doesn't appeal to you very much, and you want to get making web applications, you don't want to do the intermediate step of starting with creating a restaurant website or a personal page. Maybe you want to start with, I really want to make Facebook one day, or something similar at least. Start with JavaScript. That's where I would go. And same thing, there's so many free resources and books. If you want to send me an email or Ellie an email, my email's here, colt@galvanize.it or .com. Send me an email or talk to me after class, and I can send you specific links or resources. I have sort of a canned thing that I copy and paste often. It's like 50 or 60 links of really good resources. They're free online. But also, if you just search, there's all sorts of really, really good content for free. On the not free side of things, here at Galvanize, we do have a few offerings, and as we already mentioned, those range from data science to full stack. So there are 2 data science programs here. There's a 3-month-long program, previously known as Zipfian Academy, and that is a program that the prerequisites are a little higher. You need to have some math background. You need to know how to program already, and I can talk a little bit about data science, but that's definitely something for a whole other class or a whole other intro session. But if you know what data science is, we have a really good program here, a 3-month program, and then we also have a master's program that's a year long. So it's an accredited master's program where you actually leave here with a degree, a master's degree in data science. And then there's a full stack immersive program, which is 6 months. So we have 3 months, we have 6 months, and then we have a year-long master's program. And that 6-month program is what we've been talking about this whole time. So we cover all of this stuff here: HTML, CSS, command line, Unix, Git, JavaScript, jQuery, front end. So we have a project here, a front end project. Node.js, MongoDB, Mongoose, APIs, Express, computer science. And then you have a full stack JavaScript project. And then we cover Ruby and Sinatra and Rails and SQL and Postgres, working on a team. And then we have a team project in Rails. And the last unit is Angular React. You work on a company project with a real company in this building or in this area, where you're on a team with 3 or 4 students and you're working with a real product manager, you're working on a real feature for an existing site, you're porting something from a web app or from a mobile app to a web app, you're adding user login, you're doing real code with real situations. So it's not some contrived, make me a dog dating site. It's actually, you're working on some other contrived startup that is a real thing though. And then mobile development, interview prep, so that's a big component, and then a capstone project. So this is a lot of stuff. If you are interested, I would actually say, talk to me about this, send me an email, take a look at this slide, because this is relatively new stuff. And our website at the moment, I just sent an email about this today, doesn't necessarily reflect all of these changes. So a lot of this stuff is new. And not many places are teaching this around here at all. So things like Node, Mongoose, Express, Angular, React in particular, mobile development, all of that stuff together is pretty unique in our curriculum. And online right now, on our website, it's still in flux, and it doesn't mention some of these technologies. But here in San Francisco, we're kind of setting the pace, and we are teaching all of these things. So if this is something you're interested in, you can talk to me about it, talk to Ellie about it, send us emails. But write some of this down, or take a photo or something, I'll send it out. But the website's not the most reliable for now. I think it should change tomorrow, but just in case, just remember that all of this stuff is new, and it is what we are teaching here.
I think there's one thing you should always ask when you see, a curriculum, and the big question is why? Like, why are we teaching this A, and B, why are we teaching it in this order? I think something we spoke about, if you see in Unit 1, it's HTML, it's CSS, a couple other technologies, JavaScript. So that is strictly the front end. That's where you start. That's where the fundamentals are built. You start with front end sites. You learn JavaScript. You build your fundamentals up. The second unit, you take your knowledge of JavaScript and you move it to the back end. You start building full stack applications. You're then ready to get to a point where you can learn your second language. You understand the concepts of the back end. You understand how the web works. You can learn a new language like Ruby and all of its accompanying technologies. And then in the last unit, when you get to a point where you're comfortable with multiple languages, you're able to start teaching yourself things, you can move to the more complex front-end frameworks. So there's a lot of theory, and Colt works very hard on this curriculum stuff. He'll talk your ear off about it. But it's really, really, really well thought out. And there's a reason to it. There's a logic behind it. There's a real arc to it as why we teach and where we're going with that direction. So anytime you see something like this, even if you don't understand what SQL is or what React is, just ask why. Because it's really, really important to know, if you're going to teach me something, why are you teaching me that? And that's something we're more than happy to talk about.
So just a few points about how the class actually works. So it is not, 6 months, 5 days a week, 9, 10 hours a day of lecture the whole time. That does not work well at all. So we try and keep lecture to a minimum, or if we do have lectures, we try and make them interactive, where we have exercises, activities, frequent breaks, anything from like having students diagram stuff, having students create really cheesy skits on things to illustrate concepts, or to having students work on real projects and real code. It runs a gamut, but we have lecture is definitely a component, but it is not a college class where you're sitting down for 3 hours a day, 9 hours a day listening to a lecture and being talked at. It's much more interactive, and one of the key points that I want to bring up, it's 6 months, you're with a group of people, all who really want to be here, all who are selected to be here, 6 months together, doing a really cool thing. Most people are making a significant change in their life. And that's one of my favorite parts, is not just observing that, but being part of it. So students, I don't want to throw around words like family and community, but it is somewhere in between that, where students really do have a strong bond with one another. And you leave this class, when you spend 6 months in a room with anybody doing something really difficult and somewhat scary, and there's probably a lot writing on it for you, you're going to make some pretty solid friendships. You're going to create these bonds and relationships that last for a long time. So, this isn't summer camp, but you leave with some of the same feelings that you leave summer camp with. I'm always sad to see students go. I mean, it's great to see them get jobs, and that's why everyone's here. But it really is 6 months. You're not just showing up to class and then being booted out at 5 o'clock to have another class start. This is a place where you can hang out. It's a huge home for lots of people, where you can go to the roof for a party. You can stay down in the basement, watch a movie, and then get back to work. You can visit workshops, get food, and that's why I'm here personally. I've taught at other places that we're relatively similar, maybe shorter, maybe slightly different curriculum, but very similar in that we teach people to program. The difference really is the approach, and that's why Ellie's here as well, not to speak for him, but it's definitely a different approach than a lot of other places. So the more traditional stuff, we cover pair programming, lots of breakout sessions, events, as I mentioned, guest lectures. We have guest lecturers come in as much as possible. Outcomes focused. So we have somebody here, 2 people actually, whose entire job is to help our students get jobs. As you saw, our current placement rate is 98%. Project-based curriculum. So this is something that's really unique in our 6-month program. Every curriculum that I know of is focused on some projects, but we actually have time to focus on a real project that is with a company that actually does something. You're not creating, a stock market visualization. You might be working with a company that actually manages portfolios online, and you're working on how do I connect his Chase account to this person's actual website, or how do I connect whatever it is, real-time stock data to this portfolio website for a real company in this building or down the street, hopefully close by. So far, they've all been close by at least. So we have students actually reporting to people outside of instructors. Guest lecturers, as I mentioned, interview prep, huge consideration for us. Unfortunately, interviews don't always align with what you actually do in the job. Some of you probably have experience with that in whatever your respective disciplines are. In programming, that's definitely the case. It's rare that you get an interview that really feels like, wow, they actually tested if I know the stuff I need to know. Most of the time, interviews test, unfortunately, it's kind of just a leftover thing. I feel like computer science majors who are testing some archaic, difficult things that really don't come into play as a developer. So we're aware of that. And we build a lot of curriculum that is oriented around helping people get jobs. Whether they're going to have a great interview that is really challenging them to prove that they understand JavaScript and Ruby and databases, or if they're getting an interview that is just asking them to write an arbitrary algorithm that they're never going to use, but they need to get it. They need to know it to get in the door. And it really just matters. It doesn't matter, but it is shifting. We've seen a lot of changes in it, but there's still kind of this barrier to entry. That we focus a lot on in this class. So interviewing, interview prep, mock interviews. We start from day one. Every day we have a warm-up problem in the morning where students take a real interview question. Sometimes they spend 10 minutes, sometimes they spend an hour on it. So by the end, you have whatever that is, 24 weeks worth of interview questions. And then we have more weeks that are devoted entirely to interview prep. And the last thing, personal mentorship. So every student has a mentor here outside of the instructional staff. So companies in the building, previous graduates, we have, I guess we don't have any previous graduates yet who are mentoring, but we have people who are developers, people who are mobile developers, people who are product managers who are somehow related to web developers. And they're not personal tutors, but they're here to give you guidance. They're here to help you make decisions, to help you figure out what you should do next and learn next, and to also get you in the door at certain places. So there's a lot of things. We breezed over tons of material tonight. Hopefully some of it stuck, but the goal was not to have it all stick. It's really just to expose you to some of this. So what I want to do now is just open it up to any questions about anything we covered, like anything from, can you go back to, I don't know, HTML, can you talk about CodePen again, or anything about the program, really anything at all that we covered tonight. And then for those who want to stick around, I'll talk a little bit more, just as an optional thing, about CodePen and write some code. But it is getting late. I know most people here have work tomorrow and had work today, so I don't want to keep you here. But if you do want to see some more code being written, we'll do that afterwards.
Can you go back to the curriculum slide?
Yep.
Sweet. Thank you.
No questions? Just that?
Or yeah, I just wanted to take
Okay.
a picture of it. Sorry.
Do you want us in the picture, or how's this work?
No, it's okay.
Oh, come on. What's that?
Can you say more about the weekend workshops?
Yes. So that's actually one of the things I probably know the least about, because there's so many things happening at any given time. I have a calendar. I don't know what the public-facing version is, but I have a calendar from just internal Galvanize that has probably like 15 to 20 events a week on it, ranging from things that interest me to things that really don't interest me, but things like intro to data science, intro to web development like this, but also we had a workshop with IBM a few days ago. We had a hackathon last weekend or the weekend before. So on weekends, there's generally longer workshops. There's hackathons pretty often happen here. We've got speakers and conferences. So I don't think there's ever a weekend when the building is not being used. And Brady can attest to this, or somebody else who actually works in the event staff here, but all the time there is things going on. And a lot of them have to do with web development, a lot of them have to do, they all have to do with tech in some way usually, but a lot of them are particular to web development and to the stuff we teach in the class. So a lot of our students 2 weeks ago went to a workshop on data visualization with D3 that we had. That was just a free workshop for students only. So things like that. Right.
What's your favorite language and why?
I'll go first if you want.
So I also really like JavaScript, which is probably what you're going to say. So that's why I'm going to go first.
Alright.
So I really enjoy JavaScript. Not for, So the way I got into programming was I wanted to make things like that Ellie Goulding video, or at the time I hadn't seen that, but I wanted to make these cool interactive art installations. That's actually how I got into it. I took a class in college on that. And JavaScript lets you do that kind of stuff in the browser. So you can write like music that composes itself, or write code that composes music, that generates random music. You can define these patterns. You can define how to visualize stuff, create 3D graphics, use a webcam, do motion detection, all this stuff that is really interesting to me. It's not traditional web apps, but that's what I really like. So I try and do some workshops on that towards the end of the class. But it's also just fun to make visual stuff. I really like teaching students, how do you make something that you can see really quickly? So we used to start by teaching Ruby. I think Ruby is actually a really nice language. It's easy to learn. But the problem is when you learn it, it's all command line based. You can't see anything. It's all printing out text, characters to a black and white screen. There's no visual element. And since we started teaching JavaScript first, we've noticed students really start to get passionate and they start getting invested in the content much earlier on, because instead of making like a tic-tac-toe game or rock, paper, scissors in week 1 where it's green and black text on a screen, you're actually making a tic-tac-toe game where you click, or maybe you drag and drop your choice and you click a button and there's AI and it's visual and there's images and there's animations. And that is way more exciting for students. And it takes a little while to get excited about something like Ruby when you go from JavaScript. But I really, really like JavaScript for that reason. You can just make fun visual stuff. You can make things that are engaging. I don't know what Ellie's reasons are, probably different.
Yeah, JavaScript as well. I do agree, though, that Ruby is a really beautiful language. But I actually really like JavaScript for its future in mobile development. So I built a couple iOS and Android apps using HTML, CSS, and JavaScript, which I do think a lot of the direction of mobile development is heading in. So I think its evolution as a language is fascinating. So always trying to stay on top of it and do the latest things with it. So a lot of the frameworks, a lot of the things in Unit 4 is really where my passion in JavaScript comes in.
So you talked about the frameworks and not like reinventing the wheel. Are there people who that's what they do? They reinvent frameworks so they continue to work better, or are we just using the same old tired framework?
Yeah, that's a good question. So yes, definitely there are. So something like Angular, for instance, is over here. I don't know how many years it's been around now. A couple of years. It's come out of Google, or I don't actually, did Google buy them afterwards? They come out of Google. Yeah, so some developers at Google are working on frameworks, and actually they're working on other languages. So there's a language called Go that's come out of Google that's becoming relatively popular. Angular, React is a technology that's out of Facebook. And basically there are these teams of developers working on reinventing the wheel, yeah. But they're not just doing it just to like be nice and help other people. They're doing it because of technological constraints usually. So they're working on something like Facebook, where or Google is probably the most traffic out of any site online. I don't know the data, but I would assume. And they're trying to come up with frameworks that maybe they could use something else, but they want to improve upon it, make it faster, make it handle more simultaneous requests, or make it, whatever it is. They have teams working on that. New things do pop up though, so like 3D graphics, you couldn't do that in the browser 5-10 years ago, and now you can. So there are frameworks for that. So people are constantly innovating as well.
There's 2 questions, really just one. At the beginning, you mentioned that you think that like a boot camp specifically, this one is like the best way to go about it, as opposed to like alternative, like learning on your own, and going back or back and that. So why do you think that? And the second part of the question is really just the same questions. What are your personal backgrounds and how did you get to like?
Yeah, I think best might not be the keyword. I think fastest is probably the best keyword for that. I didn't go to a boot camp. I struggled for a while learning on my own. I was fortunate enough to have a project that kind of got me working my way up, which I think for anybody who's learning how to code, if you don't have the time or the money to do a boot camp, the best way to stay committed to learning how to do this is to have some end goal. I want to build X project. I want to build X thing. I want to do something. It's very easy to go to Code Academy and just mess around and then at the end be like, all right, cool, I know this, and then it kind of fades. So if you really want to take that journey and jump into this, have a project in mind or have something that you want to build, even going into a boot camp. I wish I had the luxury of a 3 or 6 month boot camp. I previously studied finance, worked on Wall Street for a bit, started a company, which is where I kind of learned the coding. I was the only non-technical person, and that didn't last very long. And quickly kind of picked my way up, and then always wanted to teach and ended up at General Assembly and now here. But for me, I would look at students and just say like, man, I wish I was in your shoes. And the biggest thing is it's the fastest way because you have that on-demand help. And when you learn, you're always going to struggle. And even when you keep learning, you're still going to struggle. But having someone who is a second away, who can answer your question, who can keep you learning, who can keep you motivated, that's, to me, the biggest advantage.
Yeah, and I'll add to that. Definitely, the majority of people who are developers now either learned in a non-traditional way by reading books or courses, and a lot of the people who have been developers for longer, there wasn't like YouTube, there wasn't Codecademy, there weren't really a lot of books on it. They had to read some sort of manual, they had to read like documentation online, or maybe before the internet, they had to read like a physical manual that was like bound paper. And yeah, I know, it's shocking. So it's changed a lot, but I would say that you can really, I think anybody can really learn the basics of all of this stuff. I think just like anybody can learn how to write characters, write the alphabet, and string together some words. But to become like, and this analogy falls apart a little, but to become like a Shakespeare or somebody who can write a full essay and make strong, valid arguments and support them, you generally are going to need some guidance. And you can learn the hard way. There are self-taught authors out there. There are plenty of them. And some of them write really amazing stuff. But that process of getting there, most of them just appear as wonderful writers. It's a long, long process. And so what we do is speed that up here, where you're going to fail and write horrible code a million times, and every time it's going to get slightly better, and you're going to get feedback on it, and you're going to have assessments, and you're going to realize, you know what, this thing I thought I was good at, I actually totally failed on this project, so I need to ask for help on that again. Or I need to revisit that section of the notes, or I need to watch a video on that. So we basically condense that process of what might take a few developers 2-3 years into 6 months. So it doesn't mean that you leave here and you're going to be like a perfect developer on par with somebody who's been doing it for 5 years. But it does mean that you're going to leave here and you're going to be able to get a job. You're going to be able to teach yourself everything else you need to know. You're going to be able to succeed as a developer, which really means just continuing to grow. I think I mentioned this already. When you're a developer, it's nonstop learning. You would be very, very hard-pressed to find a developer who has done the same project twice. Everything you do is different. And most of the time, nobody's done it before. Otherwise, there's no reason for you to do it. I mean, some sites, are clones of other sites, but most of the time, you're asked to write a feature taking two things and combining them. Maybe no one's done it that way before. So it's always this process of putting things together. It's really a creative process. But just like any creative process, you can't just read a book about it and be a master of it. It's not like, I don't mean to minimize like math or bio in any way, but it's not like you can just read a book on bio and know the basics and spit them back out. You can read the basics and understand them, but to be a developer, you have to like put the pieces together and build with the Legos for months and really like make things. And so Ellie mentioned that, and the projects that we do in the class are really a good way to force people to do that. So you have weeks of projects and opportunities where you have to work on something, and part of it is accountability. A lot of our students will tell you that. It doesn't matter, some people are so motivated, but somehow they find ways to not do it, and they find ways to make excuses when you get home. I've been there before. We'll keep you accountable, definitely. I usually play the bad cop, and Ellie, always gives the good news, and I have to be the one who says, sorry, you're not turning this in. Where's your project? It's a week late, and this is not acceptable. And it's not fun for me, but it is a great motivator for a lot of people. And it makes it so that nobody gets left behind, that everyone's working on projects, and they're actually doing what they committed to do. So I could talk about this for forever, but it really is a two-way street. We're here to teach you, whoever takes the class, we're here to really enable you and to guide you down this path, but it's not like we're just a book that you're going to read and learn everything. You have to put in a ton of effort. You have to make the projects. You have to build, so we'll give you the Lego set and some instructions, but you have to build the whole thing. And so it's definitely, it's a big investment of time, certainly, of money, yes, but also just in brain power. And it really means that you have to be fully committed to it. But if you are, it's going to be basically a time warp. You're going to take years of experience and condense it down. You're going to fail a bunch of times. You're going to ask all the questions that you probably would not be able to ask if you were learning on your own. But with that said, so many people learn on their own. It's very, very doable. I understand not everyone's in a situation to spend 6 months Ignoring the money aspect, there are ways of getting scholarships. We do have some loan options, but ignoring all of that, if you can't spend 6 months to do this, there are still options. And I'm happy to talk about afterwards with you. But I would really say just pick somewhere and start. And if you're committed enough, you can make it work. It might be slower. It might take you longer. Your failure cycle might be every 2 weeks or a month rather than every day. But you're still going to be writing stuff, and you're just going to have to enforce that on yourself. But it's definitely possible. So I don't want to discourage somebody who thinks like the only way to do this is by taking a class. It is just, I won't say the best, but I think it's the best way to do it fast, and the best way to do it now. Other questions?
What's that application process like? Are there any coding challenges, and what's the acceptance rate into the program?
I don't have the exact data. I'll probably let Molly talk about that a little more. Hi, Molly.
Hi, everybody. It is 1 in 3 for acceptance rate. So for people that applies, one does get in. But not everyone's ready. So we do look for more advanced beginners, so people that have tried on their own and kind of come to the end of the road. We are looking for people that know if they want to do this, if they're ready to sit in a 1,000-hour course. That's what we get added to. So if you haven't really played around with code and you're not ready yet, we don't want you to realize that you actually don't like code among it, right? Because it's a lot of effort on your part, and you made a commitment, and hers as well. So we would like you more to be an advanced beginner. So as such, there are coding challenges, but it's not. It's more sort of being familiar with the logic around it. So the instructor would more be the computer, and you would be instructing the instructor how to how to solve the problem, and you would be writing actually code, if that makes sense. So you don't actually need to have technical skill, but you need to have familiarity with kind of how computers work, so that you can instruct the instructor, if that makes sense. Yeah. In addition, we also have a pre-challenge. We tell you right up front what the pre-challenge is, and we give you the opportunity to go learn on your own and come back and give us the answer. So maybe you know the answer because you've been working on your own, or maybe you need to go and you need to study for 2 weeks, and then you can come back and you can give us the answer, and either one is fine. It's more understanding that you have done some background research and you're ready to take the next step.
Other questions?
How do you see the connection between data science and web development?
Yeah, that's an interesting question. Especially, so it's one that we think about with the data science students and our full stack students. How can they interact and how can they connect? And it's definitely, it's not the same, but basically, so I am totally out of my element talking about data science. I would love to be an expert in data science, but basically, I don't know if any of the instructors are in here, they're going to laugh at me, but basically, my quick version of it is it's using code and math and statistics to take sets of data and to garner some sort of meaning out of it. So taking a bunch of data on all of the payments Square has made, or somebody has made through Square in the last year. And then Square might have hundreds of millions of data points, and you can't make sense of that on your own. And so data science is writing code to figure out, okay, how can we use this to create a fraud protection algorithm to figure out patterns of fraud? So when somebody charges 3 times in a row from one city and moves to another city 3 times in a row, or whatever a pattern is, I'm making that up, but that is a real thing. Like my bank the other day sent me a text because I somehow triggered their algorithm that thought somebody was using my card, when in reality I just had done something that I made a bunch of purchases when I was out of town, and that triggered some algorithm. But data science is often using that data and trying to get meaning out of it. So that's one small example, but things like when you go on Netflix, they have hundreds of pieces of data about all the shows you've watched. Hopefully, possibly thousands, depending on who you are, but all the data, the movies you watched, how long you watched them for. Did you shut off a show? Did you watch 2 episodes or finish the series? Did you binge watch it? And then figuring out, based off of that, what can they recommend to you? And that's actually a really, really difficult challenge. And Netflix has a challenge, like an actual challenge out there. I forget what the reward is. It's over $1 million. If you can create an algorithm that is going to suggest something, at least, I don't know if they still have it out there. A few years ago they did. If you can create a more accurate recommendation algorithm than what they have, then you can win millions of dollars. So it's a really complicated thing. When you go on Amazon and it suggests, people who bought this also bought this, sometimes, I think I bought a few things from that. Sometimes it's horrible and ridiculous and makes me laugh, but sometimes it's really useful things. And that's what data science is focused on, and that's that's probably one section of it, and there's a whole bunch of other stuff that I don't know about, but that's the stuff that pertains to web development and data science. Because, Netflix is a website, but it's using data science principles to recommend things to you, or Amazon is recommending things to you. Web development, is any sort of website, any sort of web application. And oftentimes, so data science students will have a project. They figured out, analyzed millions of tweets and figured out how happy people are on every day of the week in the city. And then they want a website to display that in an interactive way to show that, then that's where web development can come into play. Because you could do data science completely off the web. You can crunch the numbers and create, charts and just actually print physical things out to show people. Or you can make a website to display information. So really rough around the edges overview, but yeah. Yep.
If there's someone new to coding, what would you recommend before applying? Would you recommend Coder Byte challenges or Project Tutor or Code Academy?
I would say something like Coder Byte or Project Euler is going to be, unless you have like a math background or you're familiar with some algorithms for problem solving, that's going to be a little intimidating. I would start with the basics of a language. So pick JavaScript or HTML and CSS and then JavaScript. And learn about the basics. So variables, conditionals, loops, arrays, hashes, functions, all these things. Some of you may know what those are. Some of you probably have no idea. But you can learn about them pretty easily online. So things like Code Academy. And I do want to say, Code Academy is not going to make you into a developer. That is just a really quick tool to learn a few basic things. And it's just giving you the Legos, but a lot of people assume, like, all right, I have the Legos, I'm done. But it's really just a pile of, like, plastic-colored bricks. So you have to actually do the work to put them together. And Code Academy is a great way to just get exposed to the basics, but it's the first step. So Code Academy is great, Code School is great, YouTube videos. There's often good sales on, what is it called? Udemy, is it? Where there's classes that are like 99 cents. That will be like a 40-hour course on JavaScript or something. There's lots of free resources online. I don't know if you have anything you prefer.
Yeah, I just caution with a lot of the videos and stuff. Build things, I guess, would be the best advice that I could have, because the Coder Byte challenges are fun. You might not know it, you'll see a solution, but you won't really get a lot out of it. But challenge yourself to learn the basics of JavaScript. Right? You can go through arrays and objects and conditionals, but build tic-tac-toe. Comfortable with tic-tac-toe? Cool. Try to build a more complex game like blackjack. Don't worry about all the artificial intelligence or everything, but build a very simple game that has a deck of cards and shuffles cards. Then take that, try to build something more dynamic. Think about building Snake. So just fun little games are great ways to build the behavior with JavaScript, make it look pretty with CSS, make it sensical with some structure with HTML, and you're really on your way to doing more cool front-end things. Because once you get into that creativity of, oh man, I should build a Snake game. Man, now I want to save those high scores, so I need a database. Then you can start kind of expanding your knowledge. So the code challenges are great. They're really good ways to kind of level up, especially with problem solving, but they get very boring quickly. That's the danger of them. So you go through a couple of challenges, you're like, all right, I don't feel like I got anything out of this. But when you build a game and you write the code and you see it work, it doesn't get better than that. So really strive for that kind of first step. I think would be a great way. And obviously the videos will help guide you, and you'll run into problems and you'll start Googling and you'll start going on Stack Overflow, and it's a really good way to kind of get into the mix of things.
All right, so I see lots of squirmy people. We are officially done, I guess. Feel free to come up to us, ask questions. Feel free to leave, never talk to us again, whatever you want. But we'll be here for a little bit.